Suppose we are talking about line segments, then two line segments having the same length, say A, they are congruent, isn't it? Because that's the only thing that defines a line segment, its length. We are not talking about the breadth because it does not have one. So the only thing that defines a line segment is its length, and if two line segments have the same length, we obviously say they are congruent. For that matter, if you have a square, both squares having the same dimensions, in the sense that if this side is say S, all the four sides are S. In both the figures, the four sides are same because the length of the square defines the size, isn't it? After all, the square is made up of only four line segments, each having the same length. So the entire properties of this square, its area, its perimeter, everything is defined only by this S. So if the both squares have the same length, obviously they must be congruent. That is, if you cut this piece of paper and keep it over this, they surely overlap each other. So they are congruent. Similarly, circles. A circle is finally defined only by its radius. It's only the radius that decides how big is the circle going to be, what is going to be its area, what is going to be its perimeter and all that. So if two circles have the same radius, they are congruent. So like that we can talk about any polygon. So what about triangles then? If two triangles are congruent, what does that mean? If I have two triangles, say A, B, C and D, E, F, and I say the two triangles are congruent, in which case it means that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Not only that, this side AB is equal to DE. I can also write BC is equal to EF and AC is equal to DF. So the corresponding sides are also congruent, the corresponding angles are also congruent. That makes the two triangles congruent. So this is a special case, but if this condition is not satisfied, we just have two triangles like this. Suppose I have triangles like this and let them be ABC and DEF. Now the angles, corresponding angles are congruent. Okay. So A is equal to D and B is equal to E and C is equal to F. That is okay, just like you have in congruent triangles. But what about the sides? They are not congruent. They are in the standard ratio, they are of the equal ratio. What do we mean by that? Suppose this side is say A, the length A, opposite to C is the length C, opposite to angle B is the length B here. Similarly, here it will be D, this will be F and this will be E. So these are the lengths. I am not saying C is equal to F as we had AB is equal to DE in congruent. Here they are not equal, but if C by F is equal to A by D is equal to B by E, corresponding sides, that is C and F are corresponding, A and D are corresponding, B and E are corresponding. The corresponding sides are in a standard ratio. The ratio is same. C by F, whatever the number is the same as A by D, is the same as B by E, in which case these two triangles will be similar. So they are called similar because the ratios are constant. So you have two triangles being similar only when the three corresponding angles are equal. So here again we can write angle A is equal to angle D, angle B is equal to angle E and angle C is equal to angle F. This is okay. Apart from this, we are not talking about the sides being equal, but we talk about the sides being in constant ratio. So such triangles are known as similar triangles.